Welcome to Ask and Learn.
So continuing on with physical chemistry, the first thing we're looking to do here is solve for the relationship between Ca and Ca0 at T. So Ca equal to 1 divided by 1 over Ca0. So that's the relationship, negative Kt. So in the second part, we are solving for the half-life, so it's important to note that Ca0 is equal to Na0 over V, which is equal to Po over RT by the ideal gas law. And so we can simplify this equation that we've just written on the screen and solve for T half. That is RT over Kp0. So when 50% of A conversion occurs, that is half the moles of A form half the moles of B and a quarter of the moles of C. And so the total number of moles is 1.25 Na0. The pressure we can calculate as follows. P1/2 is equal to 1.25 Na0 RT over V. P1/2 is equal to 1.25 P0. So following this, we can plot the graph of 1 over P0 versus T1/2. We get a straight line equation of y is equal to 0.007x add 0.003. With the slope, we can calculate K at 1015 Kelvin. So at 1015 Kelvin, the rate constant is equal to 0.583 litres per mole to the minus 1 seconds to the minus 1. Following this, we are able to make another plot, but this time we have ln T1/2 P0 over RT versus 1 over T. We have a straight line equation, y is 29937x, subtract 28.958. So we can use the y-intercept to calculate K0. And so we can solve for the pre-exponential factor as a result of this. .77 times 10 to the 12 litres per mole to the minus 1 seconds to the minus 1, and the activation energy EACT is 2.49 times 10 to the 5 joules per mole. So we can calculate the value of K at 980 Kelvin. That is 0.201 litres per mole per second, and then we can use the mole percentage to calculate the initial concentration of N2O, which is 0.01404 moles per litre. So the final concentration of N2O when 90% has reacted is 0.10 Ca0. We substitute all the values in for the final equation to calculate T. So we have the time required for a conversion. In this equation, 0.10 Ca0 is equal to 1 over 1 over Ca0 add Kt. So we solve for this equation to find T, where T is equal to 4,300 seconds or 71.8 minutes.